Point to balancing redox equations. So sometimes you have such an equation and you want to balance it. We use the redox oxidation number method. So this method, oxidation number method, what we do, we find the oxidation of each atom here. So for hydrogen, it's always positive one. For S, you can calculate it the same way. So it's 2 for hydrogen. We have 2 positive one plus S is X, so it's equal to 0. Rearrange it for X equal to -2. For each of this atom, you just write it above that. So it's for H is positive 1, for S is -2. For oxygen is 0 because this is pure element. Again, for S here, since this is -2, 2 multiplied by -2 is -4. So this should be +4 in order to cancel and balance it. For oxygen here is -2, here is +1. Okay, so here you write everything above. And then you see the S is changing and oxygen is changing, right? So from -2 to +4, it is going up by how much? By 6. So 6 electrons have been lost from -2. So losing electrons is oxidation. And here is 0. Oxygen number is 0 here, and here is -2. This 2 electron is gained. You gain 2 electron here, and here is you lose 6 electron. Gaining electron is the reduction. Now this is 2 atoms of oxygen, right? So you multiply this one by 2. Okay. Now, since the electron need to be balanced, if the electron of the gaining should be the same as the number of the electron is lost, right? What should I do to make these two numbers the same? Here is 6 and here is 4, right? So between 6 and 4, what is the common factor? So 6 is 3 multiplied by 2. 4 is 2 multiplied by 2. The common multiplied by uncommon. So here the 2 is common between them. Uncommon is 3 and the other 2. So it's going to be 12, right? So I can multiply this one by 2 to become 12. And this one, I can multiply it by 3 to become 12. But since I multiplied by 2, I have to put this one as the coefficient of this. And since this is multiplied by 3, I need to put it as the coefficient of the oxygen. Then I balance the other side. Now, electron exchange is balanced. Now we balance the atoms. For S here, we have 2, so I have to put the 2 here. For oxygen, 3 multiplied by 2 is 6 oxygen here. I need to have 6 oxygen here. That's why it's 4 here. So I need two more oxygen. So that's why you put 2 here. Look at the hydrogen. We have 4 hydrogen here and 4 hydrogen here, and it's balanced. So just 2, 3, 2, 2. Just want to check. 2, 3. 2, 3, 2, 2, yeah. Here's our example. So for Cl, you calculate it the same way I taught you. For oxygen, we just put all oxygen number here. You know, from +5 to -1, you're gaining 6 electrons. So you're gaining 6 electrons here. And from 0 to +5, 5 electron is lost. So losing electron is oxidation, gaining electron is reduction. Okay, we have 6 here, we have 5 here. But since here's 2 of that and here is 1, right? So it's 2 of this atom, so we multiply 5 by 2. It's 10 electron for I2. And here is 6 electron. Now we want to do common number between them. Between them, it's 30. So it's going to be this one multiplied by 5, this one multiplied by 3. That's why I put the 5 here and 3 here. Now Cl, you have 5 Cl here. I just put 5 Cl here. I, you have 6 I here. Therefore, you just put 6 there to make the I6. Now, see how many oxygen there? 6 multiplied by 3, 18. 5 multiplied by 3 is 15. Now, since now we have oxygen is not balanced, right? We have 15 oxygen. We have 15 oxygen in this side. And we have 18 oxygen here. Means how many more oxygen you need there? You need 3 oxygen. That's why you are adding water. We're adding 3H2O. We need 3 oxygen, 3 multiplied by here. Oxygen balanced. Now the hydrogen, I have 6 hydrogen here. That's why I'm adding 6 hydrogen ion at this side. Since this is an acidic solution, you will leave it like that. So the question said that is an acidic solution. That's why you have hydrogen ion here. Method, so this is another example. Now it is in basic solution. So we do the same thing. Just put the oxidation number above them. So as you can see, one of the oxidation number is changing is carbon is -2, going to +4. Means you're losing 6 electron here. So 6 electron loss for C. For Mn is from +7, turn to +6. It means it's gaining 1 electron. This is just 1 Mn. That would be just 1 electron still. There is 1 carbon here, it's gaining 36. Therefore, so between 6 and 1, you want to make them same number, right? Because the same number of electrons gained should be the same number of electrons lost. Multiply this one by 6, multiply this one by 1. When you multiply this one by 6, you are putting 6 as a coefficient. So maybe I just put that there. You're putting this 6 as a coefficient here, and here is as 1 here. Now, carbon here is 1, so you just put the 1 here. Here you have 6 Mn, so you put 6 here. Now, you're just counting the number of the oxygen. Number of oxygen here is 1 oxygen we have here, 24. So you have 25 oxygen there. Here is you have 3, 24, 27 oxygen. Means we have 2 more. We need 2 more oxygen. That's why you add water here. H2. But how many of that? Because I need 2 more oxygen, so I need the 2 coefficient 2 here. Now hydrogen is not balanced. Okay, count the number of hydrogen here. We have 4 hydrogen here. We have, and 4 is we have 8 hydrogen. Therefore, you have to add 8 H plus ion. This is a basic solution. You cannot leave it like that. You need to plus 8 OH. You add it there, and you plus 8 OH here. Now you know 8 H and 8 OH will form 8 water, 8 H2O. So 2 H2O, and here is 8. So you have to cancel these two with some of that. It's 6 H2O. H2O, right? And this is, you just rewrite it nicely to show your solution. Okay, let's just erase this. Now here's another question that you do the same thing. So I'm not going to explain that. So for practice, you can do question number 2. Now half reaction method. So this is another method. When you have HNO2 going to NO, first you can balance everything, like the atom that you have except oxygen. See, we have one N here and one N here. We don't need to put any number here, so it's balanced. Now, to balance the oxygen, you put in the H2O. So here we have 2 oxygen, we have 1 oxygen. We need to have 1 water here, so I put H2O here. Now we balance the hydrogen. Here we have 2 hydrogen, we have 1 hydrogen. I need 1 hydrogen ion here. See, we put hydrogen ion. Since this is hydrogen ion, the electron need to be balanced. I put an electron here because electron and a positive charge cancel each other, so that would be this. Here is another example. CuCu2. First you just put a 2 here to balance the everything except oxygen, right? So you put 2 here. Now for oxygen, we have 1 oxygen. I need to have 1 oxygen here. So I need to put H2O. H2O. Now the oxygen is balanced. Now I need to balance the hydrogen. Here, hydrogen we have 2, so we have to put plus 2H. Since I have the 2H, I need to balance the charge. I need to add 2 electrons here because you want to cancel this. So that will be that will be the solution. After that, since this is I wanted to do in basic solution, see, in a basic solution, I have to continue it maybe. Now we have this. The charges is balanced. Now I want to have a basic. That's why I need to cancel. I need to cancel this hydrogen. I need to have 2OH here. When you add 2OH here, you have to do the same thing to the other side because you don't want to change. So these H and these 2OH come together and form 2 water, H2O. This one of the water here and one of the water here should cancel. So you have 1 water here and you have 2OH here and you have 2 electrons there. So let's just look at the answer there. You know, 2OH here, you have water and you have 2 electrons. This is how we balance it. So let me erase this. So you do the same thing here. Now this is just in an acidic solution. When you have your H ion, so you stop there. There's another one you do in basic solution. So here is another method, balancing the redox equation using the half reaction equation. In a chemical analysis solution, dichloromate ion is reacted with an acidic solution iron 2 ions. The products form are iron 3 and chromium ion as shown by following skeleton equation. So here is balancing equation. So we just do half reduction using half reaction. So Fe going to Fe3, this is one of the reactions. And Cr2O7 going to Cr3. So what is happening from Fe2 plus to Te3 plus is losing 1 electron. So that's why you put plus here. And for this one, what you do is you find, here is Cr2O7, 2 negative to 3 plus. So you need to figure out how many of electrons used. So from 2 negative to 3 plus. Okay, so for this one, again, in the chemical analysis, we are doing, just do as here, balancing the redox equation using half reaction equation. We have this reaction, Fe going to the Fe3 plus and Cr2O7 going to the Cr3 plus. What is going on? Fe2 plus going to Fe3 plus and Cr2O7 going to the Cr3. So you write it down. So here, from here to here, from 2 plus to 3 plus, you're losing 1 electron. So you put that there. For this, you have to balance everything except the oxygen. So here we have 2 coron. That's why we put 2 here. Now we want to balance oxygen. So I put 2, I put a 7 H2O. Why 7 H2O? Because I need 7 oxygen here and I need to have a coefficient 7 here. Now I'm gonna balance hydrogen. Hydrogen, we have 14. Here is 14 hydrogen ion. Now, since I need to balance the charges, I need to add how many electrons? Looking at that, we have to come up with how many electrons. So counting the charges. So since here you have 14, charge here is 14 positive, right? Here we have 2 negative plus -2. There you have a positive 6, right? I need to know how many electrons I need. So this charge here should be equal to that. So it's 12, right? So X equal to -6 means I need to have a 6 electron here. That's why we put 6 electron there. Make sure that charges, all charges here and charges here are the same, equal. Now, then, since in the first one, 1 electron was there, I need to multiply that by 6. Everything here by 6 because I want to add these 2 reactions. So the electron gain and electron loss need to cancel each other, right? That's a transferring electron. Then the coefficient of F is going to be 6. You have Cr, so just add all right side, left side to the left side, and the right side to the right side. So let's just show you what it is here. Yeah, here it's shown as well. Just 6 Fe here. And you have 6 electron, 14 H. That is there. There's 6 Fe again, 6 electron, because this is 6 coefficients multiplied by everything here. So everything is added. Then you cancel 6 electron, 6 electron. And then that's it. You just rewrite it. Let me erase this. Now, here is another example. You do the same thing. You just have like the half reduction for MnO4. MnO4, it's go to MnO2. So you do the same method. You balance everything with oxygen. So here we have 4 oxygen here, 2 oxygen. I need 2 more oxygen, 2 H2O here. Now balancing the hydrogen, 4 hydrogen here. I need 4 H plus here. And just count all of the things here. We don't have any charges, right? Here is -1 plus 4 is 3. So I need to have a 3 electron here to cancel that, becomes 0. So here, CrO2 negative. So as you see, the C is 2 here. I need to put 2 here to balance the C and C. It's 2 negative. I need to put the 2 electron here. Now here's 3 electron and here's 2 electron. I need to multiply these whole things by 3 and this one by 2 to make it 6 electron here and 6 electron here. Then you add both sides like that to cancel the electrons. This is what you have. Since it's in a basic solution, you are canceling 8H, right? So by adding OH, so add 8 OH here, and you add 8 OH at the other side because you don't want to change your reaction. Then this will give you 8 water, 8 H2O. And you canceling 4 of that, and we'll have just 4 H2O here. And here you rewrite what you have. Okay, for practice, you can do question number 7.